be too dark over there for you guys. You okay? Like get the flashlight over everything. So we want to name each angle in the figure. So I think there's quite a few angles in this drawing. So if I could have a few volunteers come up, probably 2 people at a time can write if you're interested. We want to see all the unique angles in this drawing. Do you have any volunteers to come up? Else? Some other volunteers. Yeah, so just write one for now, and then. So then what I want someone else to do is come up and write a different one than Lena's. So a different angle in that drawing. She wrote the really big one. Anyone else? I always forget this is my shy class. My other class is like fighting over getting forward. So I'll just write some of the other ones. So someone tell me another one other than the one Lena gave us. NPR. Yep, go ahead, Michael. SPR. SPR. So you guys look. I like the order we're taking with that. Another one, another unique one, yeah.
NPS.
NPS, so like kind of that little skinny one there. Anything else? Yeah, Michael?
PN.
MPN. Did we not get that one right? MPN. Oh, no, we didn't. That means we're also missing MPS, right? Is that all of them? I think so. I see 1, 2, 3 big ones. 5 there, and then I think that might be good. Now, does it make sense why I couldn't say, hey, give me the measure of angle P? Angle P in this case is kind of like, and I can do this in my other class because it's funnier because there's multiple of them in there. But like being named Mitchell in Random Lake, like I don't know if you've realized that there's quite a few Mitchells first or last names. So like it's not very unique. Like it doesn't really tell us much about this. If I said point to angle P, which one are we talking about there? So you need to be more specific in that case. It's not being a very unique name. Like Dawson, are you the only Dawson in Random Lake that you know of? So you could be Dawson, that we don't need a first or a last name that goes with that. Like we know who you are. Same thing like like so being unique in that way. This case, angle P can't be unique. So or isn't unique. So be able to name those different angles. And notice for all of these, P though is the center of that angle. So we can't choose to name it something different without the P being in the middle. Otherwise it's no longer the angle that you see up there. So that's really important to be able to name those angles well as we go here. So we're going to talk more about angles today. We are going to do, because it's nasty outside, we're going to do a Kahoot here inside today, but it's actually going to review something from a couple of days ago, just because I think it's good to kind of keep stuff like at the front of our memory that's going to be important for our test. So we're going to go through some vocab here. And the drawing we see up at the top has a bunch of adjacent angles. Do you know what the word adjacent means? Yeah, on the side. Actually, right now, adjacent is kind of a bad word to use because that means you're right next to somebody. So right now, we can't be adjacent one another. So like, we could walk into the lunchroom and say you're sitting, you can't sit adjacent to another student. You have to be far enough away. Same thing in here. My desks used to always be in little pairs, and that can't be the case anymore. We have to be further apart. So adjacent means that the angles are next to each other, but I'm going to be a little more specific about my definition. So let me grab I want my exact definition here, so we grab that. I don't know where to put that. Like I said, the drawing has a bunch of different adjacent angles in it in our warm-up. They share a common vertex. So these are 3 bullet points about adjacent angles. So they share a common vertex. So all of them shared are the common vertex of P. They also share a common side. Which is always a ray, remember. And then the last thing is actually kind of a confusing idea until you actually see it. They have no common interior points, and I'll explain it in a second. What happened? And I'll show you an example of what that means here in a second. Make sure your mask is up over your nose, please. So I'll give us some examples, and then a lot of times with geometry, I'll do what is called a non-example. I don't know if that's really a word, but I think you get the idea that it kind of it disproves like what I was trying to show you, or shows you the opposite of it. So this is an example. So angles 1 and 2 would be adjacent angles. So angles 1 and 2 are adjacent. And the reason for that, here's angle 1, then I'm going to use a different color. Angle 2 is red here. So they share a common vertex. They share a common side. But then point E is only inside angle 1. It's not inside angle 2. So we talked about interior points last time. So E is inside 1, but it's not inside 2. So that makes it an adjacent angle. So 1 and 2 are adjacent. Now in the next drawing, there are adjacent angles in this drawing, but I'm going to specifically talk about, I'm going to compare angle 3, that's this one, to the bigger angle there, to angle ABC. Those are non-adjacent. So if you look at angle 3 there, and angle ABC, 3 is kind of inside of angle ABC. Do you see that? So they share a common side. They share a common vertex. But if I drop a point in here, that point is both in angle 3 and it's also in angle ABC. So you can't have an angle within an angle. Then it's, well, you can have that, but it's not adjacent then. So angles like on top of each other aren't adjacent. So if I said pick someone to sit next to you and then you sat on their lap or something, that would be like not adjacent. Don't sit on their lap. So angles can't be on top of each other, because they share that common interior point. Just a little more detail. If you got it, you don't have to write that down, but That's the reason why they're not adjacent. All right, so more vocab words we're going to discuss. And like I said, there's lots of vocab today, so it kind of depends how long it takes us to get through it, and then our Kahoot and stuff. So if we get through everything today, awesome. If we don't, we have to do it over 2 days, it's fine as well. So linear pair is our next vocab term. So linear pairs, first of all, have to be adjacent angles. So they have to be touching each other. So they must be adjacent. And there have to be 2 of them. Pair means 2. There must be 2 of them as well. And then if it's called a linear pair, what do you think is true of the 2 angles together? Name kind of gives it away. Yeah, Will?
A 180.
Yeah, they make that 180. They make a straight line together. So together they form 180 degrees. The name again kind of like gives away what they are. Oops, sorry. So they must be adjacent. There has to be 2 of them. And together they form a straight line, which is 180 degrees. So again, we have an example here. 1 and 2 would be linear pair. Because together, first of all, they share that common vertex. They share the common side. They're not overlapping. 1 and 2 are completely separate angles there. But together they form that straight angle, that straight line. And again, remember, a straight line can be assumed. So we know that, like, if that looks straight, it is straight. So this is 180 degrees. So angles 1 and 2 would be considered a linear pair. So I could say 1 plus 2 would equal 180. Now the next 2, if you put them together, they kind of look like maybe they make a straight line. But since they're not adjacent, I know they're close to each other, but they're not like right on top of each other, right touching each other. They're not considered a linear pair because they're not touching that same side. So they're not adjacent. Change that to So that's enough to say they're not a linear pair. Now they might add the 180 together. Maybe 1 is 60 and 1 is 30. That doesn't add the 180, sorry. It's early. So maybe they're 120 and 60, how about that? That adds to 180. Maybe that is the case, but they're not adjacent. So they're not considered a linear pair. So some of this vocab is just getting used to like what they're talking about. We're gonna use the word linear pair throughout the whole year. So just being comfortable with that term as we're talking about things. And again, we'll talk about it more. We're going to get, we'll continue to kind of mention that. All right, lots of vocab here. So flip the page when you guys are ready. Now, if there was one word that I would hope my students leave geometry knowing, it sounds really silly, but if my students leave my class without knowing what a vertical angle is, I would tell you I could probably guess their grade in this class. A vertical angle is something we will use throughout this whole entire year. When you don't know what vertical angles are, it's going to cause so many more problems kind of build on itself, kind of like not knowing a basic like Spanish word in Spanish class. Vertical angles is a term we're going to use so much. So really getting to know this term and realizing how important it is. Linear pair is pretty important. This is even more so important. And right now it probably doesn't seem useful, but we're going to use it all throughout the year. So vertical angles are formed by two straight lines. So if I could draw two straight lines and they're going to be intersecting, those two straight lines intersecting. So looks like an X. Vertical angles, anytime you see that X shape, they're going to show up there. Now the vertical angles are not adjacent. So they're not the ones next to each other. So in that intersection, there's two angles that are adjacent and two that aren't. So they do not share a side, just to make sure we reiterated that. So they're kind of the angles that are across from each other in this intersection. Across from each other in the intersection. Now we're going to learn, like I said, we're going to learn a ton about vertical angles, and you're like, really? That doesn't sound like a very important topic. It is. Vertical angles show up all over the place in this room, like in other situations. So they're across from each other in the intersection. So I'm talking about angle 1. What's its vertical angle? What's across from it in the intersection? 3. So across from it would be angle 3. So 1 and 3 would be vertical angles. That'd be our pair. Is there another pair of vertical angles in this drawing? Yeah, 2 and 4 would also be a pair of vertical angles, just another one. Now, why is this not an example of vertical angles? It kind of looks similar. Why is that not vertical angles? What is it missing? Yeah, Alec. The two straight lines. There's one straight line, and then there's this other line that's like bent. So these aren't vertical angles because they're not formed by two straight lines. So picture, two straight, as straight as you can make things. I mean, so they're not two straight lines. So that's our issue there. There's not two straight lines. All right, and so here's where like kind of the big important pieces of this, that why vertical angles are so helpful or so interesting in geometry, is vertical angles are always congruent. So they're always going to be exactly the same size as one another. So 1 will equal 3, 2 will equal 4. So they're always going to be congruent. All right, let's finish up the next 2 vocab words, and then we'll take a break from notes, and we'll do our Kahoot. Again, our Kahoot is going to be actually on something we did a few days ago. It's going to be on distance and midpoint formula, just to practice that again, because I'm afraid that you might forget that if we don't kind of practice it again. We've been talking so much about angles and segments. I don't want you to forget that for when we test, so I'm going to use that as a little bit of a review today. Now, these might be vocab words you actually you actually know from before. Complementary and supplementary is probably something that you've learned at some point. You just probably get them mixed up from time to time. And I'll give you my trick on how I remember the difference. So complementary and supplementary angles. Do you know that? Does anyone know what they are? Like always, the ideas go together. Do you think you know?
They always add up to a specific angle.
Yeah, so it's either 90 or 180, or complementary and supplementary. So remembering the difference between them, and this is the way I remember, and this might work for you, and then others of you just don't think that way, and you'll find another way. So I like things being in order. So I'm a math teacher, so here's my kind of OCD, crazy ways of ordering things. I order things, obviously it's not that crazy because people do it all the time. Order things in alphabetical order. So C comes before S. If we're talking about 90 and 180, which comes first? 90, right? So complementary are always going to add to 90. Supplementary are always going to add to 180. So just put them in order, so in alphabetical order. So complementary angles are two angles that add to 90 degrees. And now complementary don't have to be adjacent. They can be. They don't have to be. So it's two angles that add to 90 degrees. Now, both of these are examples of complementary angles. They don't have to be adjacent. And then this one, how do we know these ones are complementary? How do I know they're complementary? Yeah, go ahead, look.
Square.
Because of that little square there. You see that? It's really tiny. So they don't have to be adjacent. So 1 and 2 would be complementary. A and B would be complementary. So they don't have to be adjacent, but they can be. So they add the 180 or 90 together, sorry. And then again, supplementary are two angles that add to 180, but again, the reason they're different from a linear pair is because they don't have to be adjacent. Now, a linear pair is supplementary, but supplementary don't have to be a linear pair. So two angles that add to 180. And so again, in both of these cases, they do not need to be adjacent. Now they can be, but they don't have to be. So that's important to be aware of. So long as I have an angle that's 60 and 120, they add to 180, those are supplementary angles. Okay. So I think we're gonna take a break for notes because you guys have been writing a long time, sorry. That's partly why I like writing them as I go as well, to remind myself it does take a lot to write notes that long, so apologize for that. You're going to want to get your laptop out, but then you also might want scratch paper. So you can either have scratch paper, or if you prefer to use a whiteboard, you guys can do that. But you'll want to get your laptop out to do your Kahoots, and then again, scratch paper or like a whiteboard if you prefer. You probably want a calculator handy because we're doing distance and midpoint. So if you have a calculator. If you don't have a laptop today, a phone is okay, but I prefer that laptop. You don't have your laptop, you have a phone instead. Those of you online, this won't be live. Feel free to follow through the examples, though. And I do prefer when you do a math Kahoot that you do use your own name or like something that I would recognize. That way, if you're really struggling, I can know and help you. You need to be plugged in.
Yeah.
So if you just want to go to like the chair over there, if you can see from over there. You can slide a desk over there. It's plugged in there. And some form of your name that I would recognize so that I know, like if I'm like, oh gosh, Michael has no idea what's going on right now. I use that as you do. I would be able to like be aware of that so that you can see the results later on. Obviously, as a group, I'm not going to call you out or, but. Do we need music? Can you only do it completely? I'm still getting used to people's names, so like some of the names, like at first I was like, is there a Gabe in here? It's not Gabe. It's Gabe in this class, but I have to remember what classes you guys are in. My classes all kind of been blend together. You could show up at the wrong time and I would probably just teach you.
Yeah, might as well.
Just stay all day in math class, like Miss Miller has to. And so again, you'll want scratch paper. You'll want the distance and midpoint formula. Do you guys even remember those? That's probably why we're doing this. So, so distance and midpoint, remember, are the two formulas we learned. Write them on the board up here. And I'll leave them up. Remember, we have to follow order of operations with them. And then midpoint is where we find a coordinate point. It's a really similar formula, but just different enough to be confusing. So you're going to want those two formulas for our Kahoot today. I don't know if you can see those. I don't think so. Here. Just waiting, I think I have one more pair or two more. Of course, there's fabulous prizes. All right, you ready? I think we're all good. What's the midpoint between these two? So again, you're looking at the midpoint. Those are the points up there, 4, 1, and -2, -3. They give you like a full 2 minutes. We probably don't need that much time. So midpoint formula is the second formula where you add the x's together and divide by 2 and add the y's together and divide by 2. Again, you shouldn't feel right. I mean, obviously the faster you answer, the more points you get, but it's better to be right than wrong and fast. And sometimes being smart about multiple choice questions a little bit, like you figured out one of them and it works and it there's not another one like that, then you can eliminate some of the other answers. Fill up over 30 seconds. Yeah. Okay, so guys, on this one, most commonly missed obviously was the one that was really, really similar. So in this case, if I add the y's together, so it looks like this is where most of you guys went wrong. If I do 1 plus a -3 and divide by 2, because the y's you're supposed to add together and divide by 2 as well, that's going to be a -2 divide, sorry, that's really messy, divide by 2. And that's where our -1 comes. -3 is bigger, so that's why it's -1 and not +1, right? So don't give up if that's the only one you get wrong. Who knows, you're still in this. But again, I want to know who's understanding, who's not. So even if you're getting questions wrong here and there, like making sure that you're doing your best to try and get as many right as you can. This is not a grade, but all right, there's our leaderboard. Next one. So again, just another midpoint formula, same idea. Give you the coordinates. Yeah. Send it later, but yeah, you can just put it on there now. We'll send it up first. Yeah. It'd be nice to be able to go back to that email and say, "There's my link right away." Yeah. I'm trying to think, yeah. I was gonna see if my rival, the Q 504, we will put that up. Let's go there. Yeah. I think, yeah. Yeah. Notice there's decimals here, that's okay, they're not terrible decimals. Still have about 30 seconds. All right, much better. Good work, guys. So yeah, just be careful. You're adding the x's together and dividing by 2, adding the y's together and dividing by 2. We need to change there. Nolan a little bit faster. All right, I can't remember what this one is. I throw some fun questions in there. Sorry, this time they're sports. If you're not a sports fan, sorry. And I think they're pretty easy sports questions, so hopefully, yeah. So this is the only sport so far that's had competitions this fall as a school sport. Everybody else, they started practice, but this one's actually had, yeah, football and all the other ones haven't actually had like a game yet, like a real. I understand, lead change there. All right, so back to math. Now they're asking for distance this time, guys. That's the big square root formula. Oh, they put it up there for you. Distance formula for between those 2 points. Again, you have a full 2 minutes. You notice they just did decimals or left it as a whole number. You want a calculator probably. Unless you're really good at square roots in your head, which would be impressive. Don't forget, guys, when you square something, it always becomes positive. So any number squared is going to end up being a positive. So if you have negative 21, it's telling you right now you're wrong. Sorry. But anytime you square something, it's going to become a positive number. Sorry, only about 10 seconds left. You might have to make a good guess if you're still waiting. All right. All right, so let's talk about this one because obviously we're a little bit rocky on this, and that's okay. That's why we're reviewing it. So the distance formula, we take the x's and subtract them. So negative 5 minus 4 squared plus negative 9 minus 2 squared. Now if you're like, oh, I went in a different order. The order is up to you as long as you're consistent. So if I'm subtracting this from that, I have to do that both times. I can't like switch what order I subtracted. Bless you. Same thing, these can be flipped. It really doesn't matter as long as you're consistent. So this becomes a negative 9 squared. This is a negative 11 squared. Now again, anytime you square a negative, it actually becomes a positive. Something negative times itself is just going to be a positive. So this is 81. This is 121, right? It's going to be at 202, is that right? So we're at the square root of 202. Now, even without a calculator, I probably could be a pretty good estimator that I know this is going to be somewhere around 36. You know, so I can eliminate that one, obviously eliminate that one, and then so the square root of 202 must be 14.21. All right. So definitely a little bit tougher. We're going to have more distance formula ones to practice. So that one didn't go well. You get another chance at it. And leaderboard change there a little bit. So again, distance again. So use that. Don't worry about the graph, but use the distance formula. If you guys can't see where you're at, you might want to move up or whatever. Sorry, the numbers are too small. Okay, you should have a full 2 minutes here. This one might be a little bit easier. Some nicer numbers here. Something good kind of happens in this problem. Love, like, I feel like it's like yoga music. No, it freaks out at you. Good work, guys. Much better. So the big one on this one is 4 minus 4 ends up being 0. So that part cancels completely. And so then when I subtract the other one and I square the 11 and then square root it, it ends up being 11. All right, leaderboard stays the same. I always love when they highlight just Julia. She's got the answer straight, even though all of you guys do. So another distance 1. Again, distance between those 2 points. A little nervous some of the later questions are ones we skipped, so I might end up skipping some of the questions. Alright, so almost perfect, but not quite. 2 people everywhere here. So we do 4 minus 0. It's just 4 squared. 0 minus 5 is negative 5 squared. So 16 and 25, remember, becomes positive when you square it. So that's how we get, what is that? 41? So we do the square root of 41, which gives us our 6.4. All right, I think the next one might be not math question again. I think it's a sports one. I'll try to vary up what I ask, but I don't know. Oh yeah, sad.
I don't know.
Well, the pitcher helps, sort of, except that he didn't play last night.
He didn't play?
No, he is pretty good.
Come on.
I know.
This is-
And it was within reach. Like, it was so, like, it was close. But yeah. As far as I know, the Timberwolves are not in the playoffs, but I'm not sure. So if the Timberwolves lost last night, sorry. Again, the next couple questions, I'm not sure. They might be questions of things we skipped. If it is, I might just jump over and we'll kind of see. Can't remember. These no one got knocked out of the leaderboard over the sports question. Oh, so just asking for midpoint again. So again, midpoint. So change gears back to midpoint. It's up here if you forgot.
Wait,
Midpoint. So add the x's, divide by 2. Oh, did you?
I accidentally hit this.
That's why the phones are dangerous to do these on, because you go to like swipe to like get it out of the sleep mode. It was raining last night in the rain, in that crazy rainstorm, because my weather thinks that it wasn't really supposed to rain. I don't know why I believed it, but I was stuck in the rain running, and I had my phone, and my phone was hitting my pocket, and it disabled itself, because you know when you hit it too many times or whatever. So I looked at it and I was like, oh man, because the next thing it was gonna do was like call, I think like it asked if I wanted to call like for help. So so I almost had like the police come.
Is the red and the yellow the same?
Are they?
Yeah.
Yes.
So I'm getting
We'll see. Are one of those the right answer?
what's
It's not the right answer anyway, so. So don't choose that one. Yeah, so this is -3 and then divide by 2. All right. Again, another midpoint. Oh, I've never had this site. Yeah. a good one this year too. There's good things on it, yeah. It's getting better at this midpoint here. All right, oh, look at you guys. Some experts. Last question. So again, sorry, I tried to make it really like,
I don't know.
if you like live in Wisconsin, I hope you know this person, but maybe not. Brian Braun's a baseball player, sorry. All right, here's our podium.
I'm sold.
Yeah. Yeah. Did anyone else that didn't make the podium have a perfect score? Like you were in the top 5? Okay, so if you, so if you got a perfect score still, but didn't make the top 5, come on up still.
No.
So top 5 plus whoever had a perfect, I think there might be more of you.
No,
I answered.
they would answer mine. Yes, come on, yes. I don't want this.
Alright. So guys, before we're done here today, I'm gonna skip over the perpendicular line vocab. So if you wanna, clean up your stuff, and we'll finish up with this last example. I guess it's 4 examples. And then we're gonna alter the homework. So just so you guys know, our test is probably gonna be next Monday instead. So we'll do 2 days of notes with this, and then we'll test Monday instead of Friday. So we'll alter the homework just that you guys know that is coming up. So if you want to go to this example, so you're going to have to flip the page. We'll do this example and then we'll be done for today. I have to replenish my candy supply. There are many options here. I keep saying Halloween's not going to happen. All right, so if you want to skip ahead to this example, we're going to skip the vocab on perpendicular. We'll come back to that next time. So they want us to name 2 adjacent angles in this drawing. So remember what adjacent are. The word adjacent means next to, so think of like a partner, but they're sharing a side. So like, you know, when you have a close friend that you're okay with sitting right next to them, that would be your adjacent angle. So someone give, well, let's actually start with, why don't I'll use this angle here. So let's start with LTN. What angle is adjacent LTN? There's a lot of options, so we'll give you one of them. Go ahead, Lena. LT what? LTR. So LTR would be adjacent. So those 2 are next to each other. They share that common endpoint. They share their common side. Adjacent angles don't need to add anything in particular. So these 2 are adjacent. They are next to each other. That's perfectly fine. Okay. Name 2 acute vertical angles. So anytime you see the word vertical angles, think about that X shape we talked about. So something like that. Vertical are always across from each other. It's like here and here, or the opposite. So what do you think, Luke?
STR and LT.
So he said STR. So this one. And then he said LTE, which would be over here. So again, they form that X shape, so the blue kind of helps you guys to see it. And remember, vertical angles are also equal, so I can use the equal symbol and LT. Now, he picked they asked for 2 acute vertical angles. There are other vertical angles in this drawing. So you could kind of come up with that, but they're asking for acute, and those would be obtuse, the other 2. Name 2 supplementary adjacent angles. So they're supplementary but also adjacent. We could also call that a linear pair. Supplementary adjacent angles. Supplementary means they add to what? 180. Remember, supplementary is the second one, so that's 180. They should add to 180, and they're next to each other, and they add to 180. So we have to make 180 together. So do you want to use the ones on the bottom down here? So RTS and STE work. I guess we kind of answer the question down below then too. Name an angle supplementary to RTS. It would be STE, could be one of them. Okay, so what we're going to do, like I said, we're going to alter homework slightly here, or actually quite a bit. We're going to end up doing the whole thing, so don't like cross out like all the extra numbers, but we're going to change it for now. So what you're going to do for tomorrow, and it might be a little bit for Thursday, we're going to do, they're all going to be odds, so 3 through 15, and then 21 through 27. So all odds for that, but we're gonna wait on the other ones. All the other ones involve algebra. We haven't really done much algebra with this. So we're kind of shortening it up for tomorrow. We're gonna end up doing all of it for Friday, but so 3 through 15 and 21 through 27 odds. The same pages though. Still the 38 and 40. That should still be posted online, it's just the numbers are wrong on them. And I just reserve the right to do that at any point, just not to push us too fast if we aren't ready to, or if I just don't get through all the notes.